The importance factor K4 is the importance factor for cyclonic region K4, which is the structure is located in Chennai. Therefore, K4 is equal to 1.15. Design wind speed V is equal to VB into K1, K2, K3, K4. Therefore, VB is 50. If you multiply with all the factors, you will get what is the design wind speed Vz. This is the wind speed you are going to consider for the design. But actual basic wind speed is only 50 meter per second. Then design wind pressure PD you have to calculate. For that, you have to first convert this Vz, that is wind speed, into a pressure. That is the formula which is given in code, 0.6 into Vz square. If you multiply, you will get in Newton per meter square. That is your Pz value, that is 2.254 kilonewton per meter square. Design wind pressure PD is equal to Kd, Ka, Kc into Pz, and also PD is less than or equal to 0.7 times of Pz is the formula which is given, or the restrictions which is given in the code. Therefore, Kd is your directionality factor as per clause 7.2.1 if you refer. For buildings, Kd is equal to 0.9. Area averaging factor, you have to find out what is the member you are going to design it. In this, we are going to design the purlins. Therefore, the area averaging factor is nothing but the effective area or the tributary area of the purlin, that is 1.67 into 4, which is equal to 6.68 meter square, which is less than 10 meter square. Therefore, my Ka value is 1. Then Kc is your combination factor. As per this class, if you see, it is value is 0.9. So if you multiply all this with the wind pressure which you have converted from your basic design wind speed, this PD is going to be 1.83 kilonewton per meter square. Now you are going to find out what is the wind load acting on the individual purlins. In our case, purlins. Individual members, in our case it is purlins. So F is equal to CPE minus CPI into A into PD. Cp is your external pressure coefficient, CPI is your internal pressure coefficient, and PD is your design wind pressure. So for internal pressure coefficient, as we have discussed earlier, it depends on the percentage of openings given or in the building. Since it is not given normally for the sheds or any type of structure, it is going to be 5% to 20% of openings. So we consider this percentage and find out what is CPI is equal to plus or minus 0.5. External pressure coefficient, when you refer clause 7.3.3, it depends on, you have the tables which is given. For roof, you have to consider, because purlin is going to be rested on the roof. So you have to consider for the roof. For the roof, your H by W is 12 meters is your height of the building, and the span of the truss is also 12 meters. So it is going to be 1. It lies between this factor, that is 0.5 to 1.5. So H by W lies between 1, and if you refer the table, you will be able to find out what is the windward side, leeward side, that is coefficients. If you see, this figure is given in the code itself, that is EFGH. EF is nothing but when your angle of wind is theta is equal to 0 degrees. When the wind acts in this direction, this is your windward side, this is your leeward side, and these two are your sideward side. We are going to design only the truss, so we are going to consider only about the windward and leeward, not about the sidewards. Now windward side is EF, leeward side is GH. When theta is equal to 0 degree, this is going to happen. When theta is equal to 90 degrees, windward side, that is this side, if you see theta is equal to 90 degrees, EG is your windward side and FH is your leeward side. Now CPE you have to find out. We know what is the angle, 26.57 degrees, but in code it is given for 20 degrees and 30 degrees. So for theta is equal to 0 degrees, what is your windward, what is your leeward, and theta is equal to 90, what is your windward, what is your leeward. You have to take down the values which is given in the code and linearly interpolate and find out the values for theta is equal to 26.57 degrees. So these are the 4 values you are going to use for the calculations further. Now, since our formula tells that CPE minus CPI into area into design wind pressure. So in this table, you are going to calculate except area, what is your CPE minus CPI into design wind pressure. So you know what is your PD, design wind pressure, that is 1.83 kilonewton per meter square. You know your external coefficients, theta is equal to 0 degrees, windward side, leeward side values, which we have calculated in the previous calculations, minus 0.372, minus 0.5. CPI value based on the percentage of openings, you have two values, plus or minus 0.5, because there is a positive internal pressure might be there and negative internal pressure will be there. That is vacuum. So plus 0.5 minus 0.5. This is CPE minus CPI. Therefore, CPE value for windward, two values you have to calculate, for positive CPI and for negative CPI. That is why I have calculated for windward two values, minus 0.372 minus 0.5. That is CPE minus CPI. CPI value is positive, means you have to directly minus it. So minus 0.372 minus 0.5, both the signs are same. So it is going to be additive, that is minus 0.875. Next, I am going to calculate minus 0.372 minus of minus 0.5. This is going to have a positive effect. So minus 0.372 plus 0.5, that is why my value is positive here. Now I'll calculate same for the leeward side also. Minus 0.5 minus 0.5, it is going to be minus 1. Minus 0.5 minus of minus 0.5, this is going to be 0. Similarly, I'll calculate for theta is equal to 90 degrees. Out of these four values, CPE minus CPI, which one I am going to consider? That is the one, because PD is going to be same. PD is same, that is 1.83 kilonewton per meter square. Area is also going to be same for the purlin. So it is 1.67 into 4. So the only thing which is going to influence is your CPE minus CPI value. Which based on magnitude you have to see, not based on your sign. That is, whether it is positive or negative is not going to have to be considered. Only you have to consider the magnitude alone. That is 1.3 here. It is 1.231 here. So minus 1.3 minus 2.31. Here I have considered for, that is minus 2.31. What you have to do is you have to calculate for minus 1.3. Here I have calculated for leeward side and you have to calculate for windward side, right? So minus 1.3 you will calculate, and I finish this calculation using minus 1.231. So based on magnitude, this is not going to have a change, but the thing is you have to consider the magnitude. Why I have considered two, I am asking you to consider two values is, this is on the leeward side and this is on the windward side. If you see that this both is going to have the same impact if you analyze the truss in case of a truss as a whole, right? So minus 1.3 into area you have to consider into PD. This is around 2.253 kilonewton per meter square. I have completed the calculations using minus 1.231 into PD, which is around 2.253 kilonewton per meter square. Now, what is a wind load? This is your CPE minus CPI into PD. This is your 1.67 is your spacing of purlins, correct? And 4 is your span of the purlin. So this is going to be your total load. Here I have mentioned only the magnitude, not the sign. It means that it is negative, so it is suction, or in other words, it is away from the structure. So your load is 15.05 kilonewton of force is going to act away from the structure, and dead load and live load you have calculated. This is how you have to calculate for dead load, live load and wind load for the design of purlins. Thank you.